This is Geometry Unit 6, Lesson 11 on indirect proofs. Now, what we're going to be looking at with indirect proofs is how they are different from direct proofs. Direct proofs is what we've been doing so far in this unit. A direct proof is a proof that starts with givens and then uses deductive reasoning to lead to what is proved. So we take a statement, we draw a conclusion, we take another statement, draw a conclusion until we get to the final conclusion. So let's look at what a direct proof is and then compare it to an indirect proof. Now, we have a theorem that says if a triangle is isosceles, the altitude from the vertex angle bisects the base. In other words, the altitude from the vertex is also a median. So we are going to prove, if we have an isosceles triangle where we have an altitude, we're going to prove that CD bisects AB. So let's see how we're going to do that. So I have my altitude here, and I have my isosceles triangle. So that probably I want to prove that these two triangles are congruent. So let's see if we can do that. Well, I'm going to start out with my statements and reasons, just like we always do. We have isosceles triangle, ABC, with vertex C, and that's given. So what does an isosceles triangle mean? Well, if we have an isosceles triangle, that tells me I have AC and BC are congruent. AC is congruent to BC, because an isosceles triangle has two congruent sides. So we have that. Then we have CD is an altitude. Well, here is CD, and that's an altitude. What does an altitude do? Well, an altitude is special because it is a segment that is drawn from a vertex perpendicular to the opposite side. So CD is an altitude will tell me that CD is actually perpendicular to AB. So my statement is CD is perpendicular to AB, right here, forming this at the bottom. All right, now what does it form at the bottom if this is perpendicular? Well, it makes right angles. So we know that angle ADC and BDC are congruent right angles. So let's put that down. Perpendicular lines form congruent right angles. So there are my two angles that are congruent. Now, I have to decide how I want to prove the triangle is congruent. These are right triangles, so we could either use hypotenuse leg, or we could use, if we have a side and an angle, probably angle side. So we have to decide which we want to use. I'm probably going to use, let's use hypotenuse leg just for practice, because this is a right triangle. So I want to, first of all, because I'm going to use hypotenuse leg, I want to say this is a right triangle. So triangles, I should say. Triangle ADC and triangle BDC are right triangles, because right triangles have a right angle. So there we go. So there's my first part. I proved it's right triangle. Now, do I have the hypotenuse? Well, let's see. Here's my right angle, so my hypotenuse would be here. So I've already got the hypotenuse together right there. I've got that proved. Now, where would my leg be? Well, my leg would either be AD or BD and CD. Well, let's use the reflexive. Let's use CD. CD is congruent to CD, and that's by reflexive. And therefore, the triangles are now congruent by hypotenuse leg. Triangle ADC is congruent to triangle BDC by hypotenuse leg. Now, we could have also proved angle A congruent to angle B and used angle side. A would be congruent to B because they're base angles of an isosceles triangle, but hypotenuse leg is good practice. So now we want to prove that CD bisects AB. Well, how do we know this segment's bisected? Well, when it's divided into two congruent parts. Well, since these two triangles are congruent, isn't AD congruent to BD? Yeah. So AD is congruent to BD because of our favorite 5 letters, CPCTC. So since the triangles are congruent, those segments are congruent. And because those segments are congruent, that means that CD must bisect AB. So CD bisects AB because a bisector divides a segment into two congruent segments. We proved two congruent segments in the previous statement. So a bisector divides a segment into two congruent segments. And we have it. We have proved what we want to prove. Now that is a direct proof because we took each statement and we drew a conclusion from it to come down to a final conclusion. So we proved hypotenuse leg, proved the triangle's congruent, and used CP/CTC to prove what we wanted to prove. So that's a direct proof. Now we're going to look at an indirect proof. An indirect proof is a little bit different. It is a proof that starts with an assumption. This is the only time that you can assume something when you're doing a proof. It's a proof that starts by assuming the negation or opposite of what you want to prove, then use deductive reasoning to prove that your assumption is false. So you're going to assume something's true, and what happens is you use that assumption, and then you come to a conclusion that's wrong. So by proving the negation of what you're trying to prove is false, you can say what you are trying to prove is true. So you are trying to find what's called a contradiction of what you know is true. So we want to prove that one of the statements that we made is actually false by the assumption. All right, and if the assumption is false, the assumption that we made is false, that means that's wrong, and therefore the opposite of it must be true. So when you make an assumption, you want to assume the opposite of what you're trying to prove. Okay, so let's make an assumption on here. We are given the measure of angle CDE is not equal to 90 degrees. And we want to prove that CD is not perpendicular to DE. Well, that's kind of an obvious one, but let's do it by using a kind of indirect proof. What assumption would we make? We would make the negation of what this is. So CD is not perpendicular to DE. We make the assumption that CD is perpendicular to DE. Okay, now if we think about this for a second, if we make that assumption, if CD is perpendicular to DE, that leads to the conclusion that we have a right angle. Angle CD is a right angle that measures 90 degrees. So that the CD is a right angle that measures 90 degrees. But what were we given about CDE? We were given that CDE is not 90 degrees. We know this is true. That's true. We were given that fact is true. All right, so that implies we know that measure CDE doesn't equal 90 because that's given. So what does that tell us about our assumption? So our assumption has got to be false. And that means that since our assumption is false, because we have a contradiction. We have a contradiction. The contradiction is, based on our assumption, we said this, that CDE measures 90, but we really know it doesn't, because we know that's true. So that is called a contradiction. Oh, I forgot the N in contradiction. That's a contradiction. So, by making this assumption, we prove something that's not true because we knew it was really false. So that is that's kind of an indirect proof. Shorthand. All right, let's take a look at this one. EG bisects angle DEF. And we want to prove that angle DEG is congruent to GEF. All right, now we kind of know that's true, but let me draw a quick picture here. Here is angle DEF, and then I have EG, bisects it. All right, so here's my angle, and it's going to bisect it. So that's my given. All right, however, I want to prove that DEG is congruent to GEF using indirect proof. So my assumption that I'm going to make is I'm going to say these are not congruent. Angle DEG is not congruent to angle GEF because I am negating what I'm trying to prove. And if I'm negating that, I'm going to assume that the statement's true. All right, so if DGEG is not congruent to GEF, could this be bisected? So based on that assumption, EG would not bisect angle DEF. But we know that it really does. All right, based on that assumption. So we actually have a contradiction again. So that means the assumption is false. So there we go. And what we wanted to prove is actually true. Because this is wrong, this must be true. So it's kind of a roundabout way of proving something. When you're using an indirect proof, most of the time you're trying to prove something is not true. So let's try an actual problem. All right, so we have given that triangle ABC is not isosceles and CD is an altitude. And we want to prove that CD does not bisect AB. Now usually when you have a not, this is when you want to do an indirect proof. So let's start out with our assumption. CD does not bisect AB. So my assumption is going to be that it does bisect. CD bisects AB. And that's going to be the assumption that I made. I actually don't know if that's true. I'm just going to assume it is. So by making that assumption, if CD bisects AB, here's CD, here's AB, I can say that these two segments are congruent. Even though they don't look like they are, based on our assumption, we're thinking they are. So AD is congruent to BD, because a bisector divides a segment into two congruent segments, just like we normally would. Into two congruent segments. So now, I know that. Now, I want to prove that triangle ABC is not isosceles and CD is an altitude. I want to prove that it really is an isosceles triangle. So if it was an isosceles triangle, AC and BC would be congruent, and then it would be isosceles, but that's not really true. So what I'm going to do is I'm going to prove the two triangles congruent, and then prove that this is an isosceles triangle when it really isn't. So let's go from there. We have the next thing, we're going to prove these two triangles congruent. CD is an altitude. And that's given. And altitudes give me perpendicular lines. So CD is perpendicular to AB. And that's an altitude is drawn perpendicular to the base from a vertex perpendicular base. Perpendicular to the base. So that means that these two angles are right angles that are congruent. Angle ADC is congruent to angle BDC. And that is by perpendicular lines form right angles that are congruent. Form congruent right angles. And then using the reflexive CD, I can prove that the triangles are congruent by side angle side. So triangle ADC and BDC are congruent by side angle side. So therefore, that means that AC and BC must be congruent by CPCTC. So that makes ABC an isosceles triangle. Because an isosceles triangle has two congruent sides. But problem is we have a given here that it says is not isosceles. That's given. So if that's given, it's not isosceles. That is what's called a contradiction. We prove something that isn't true. So that means that what we tried to assume is false. So we can say CD does not bisect AB. And therefore, my assumption is false. And what I wanted to prove is true.